Right? Now we need to look at the mechanism, right, of our aldol condensation type of what call like reaction. So remember we said we treat that two aldehydes, treat them with what? With a base in this case. So what will happen here, the chemistry here is that you've got a carbon atom here that is double bonded to oxygen. So here you've got a sigma bond and a pi bond. So if you look at the sigma framework, oxygen is much more electronegative than what? Than carbon, right? And therefore, the oxygen atom pulls the what? The electron density towards itself. As a result, it assumes a sigma negative charge, right? Whilst the carbon atom here assumes a sigma positive charge. Now, at the alpha position, you've got an alkyl group there that releases its electron density, right? So you've got more like an inductive effect here that started here, your oxygen pulling the electron density away from the carbon atom. Now there's the carbon atom, it's positive. Now the carbon atom, right, is bonded to an alpha carbon atom. Now this becomes positive. Then what happens then after, like, it pulls the electron density away from where? From the alpha carbon atom. Now there's the alpha carbon atom, right? The alpha carbon atom is bonded to hydrogens, right? To hydrogens. Now the hydrogens, right? Now the carbon atom at the alpha position pulls the electron density away from the hydrogen. So this alpha hydrogen atoms there now, the alpha, they are loosely held. They are loosely what? Held, and can easily be knocked off by what? By a base. So that's why we have this reaction like this. This comes in here to pick this one up. Now, this hydrogen leaves its electron density with this carbon atom to generate what we refer to as like a carbanion. There we go, right? First, what we form here? This double bond, O, 1, 2, 1, 2, this to hydrogen, right? Then remember, there is one hydrogen now that is left there now, with a lone pair here. There's our lone pair there, and then at the alpha position, which is negatively charged. Do you see that now? Now, that charge is resonance what? Stabilized. That charge comes here because there's a source of electrons, single bond, double bond. Then there will be a movement of electrons here. Right? And then as soon as these electrons come here to form a double bond, these ones go out. Then you form an enolate, right? Of what? That is 1, 2, 3, 4 of your, what do you call, like the butyldehyde, right? Then you end up with this system here. This will be 1, 2, this, there will be a double bond here now. This O, 1, 2, 1, 2, 1, 2. This is what? Negative. And that there, hydrogen. There we go. We close here. There we go. We close here. Right? Now remember now here, what have we formed here? Remember, don't forget, you have formed plus water as your byproduct, like in that particular step. So this is your enolate, right? Formation of your what? Of your enolate. So that's the first step here, like in this mechanism. Now that you've generated your enolate, right? Now we're going to the next step now. Next step, it's going to be, there we go, here, this, that, double bond O, 1, 2, 1, 2, 1, 2, 1, 2. Then there's a hydrogen here. Here there's only one hydrogen. 1, 2. There is a negative charge here. Right? There's my negative charge. This is beautiful. I love this. Right? Now remember, it's going to react with the second aldehyde. Remember, your aldol condensation, aldol condensation, aldol condensation, aldol condensation, aldol condensation, right? You must have two aldehydes there. Remember, we had the second aldehyde here. Sorry. So we had, let me just write it neatly. There we go. There we go. Now, there we go. Right? What's going to happen now, like this now, carbanion, then it comes in here to attack this carbonyl carbon directly. Right? And then those electrons now, like, they are taken to oxygen. So this is the condensation step. This is the what? Condensation step. You are combining now, like, these aldehydes in this case, right? So what do we end up with here now, right? Let's go. This, that, there. There's a double bond there. Oh, 1, 2, 1, 2. Then there's what here? Hydrogen. This is bonded to what, you know? A new bond to this carbon atom, right? This carbon atom, it's bonded to this here, bonded to this, bonded to that. The same carbon atom here, it's bonded to what? To oxygen. 1, 2, 3, 4, 5, 6, which is what? Negative, isn't it? Remember there was this hydrogen that was attached there. I'll just put it there. There we go. Right? Now, we recall here that, like, we had water. We had water, right? That we produced in that step there. Water is H, bonded to O, bonded to H. 1, 2, 1, 2, 1, 2. Isn't it? Now, what happens now is this now minus here goes out to pick up this hydrogen from your from your water, as the hydrogen leaves behind the bond pair that it shared with what? With oxygen. Then what then do we get now? Like, we end up with this structure. Let's go. This here, that double bond O. This here, hydrogen, 1, 2, 1, 2. Then this here, that here, right? There's your hydrogen there, and then there is your OH there, your OH there, right? Then I can write it nicely now, right? Let's go back to our target molecule, the way, like, you know, like, the way it was shown like to be like this, that, in this case, this, what do we have? Sorry, this here, okay, let's see, 1, 2, this is 1, 2, 3, 4, 5, 6, 7. So here we had C double bond O, then we had H here, 1, 2, 1, 2, 1, 2. Now, 1, 2, 3, at this particular position, we had our OH, if I'm not mistaken. We had our OH here, right? And then here we had something like this, that. 1, 2, 3, 4, 5, 6, 7. Yes. Then 1, 2, 4, 5. No. I think, yeah. What did we have here now? Was it something like this? Okay, let me just check this one out. I'm not making any mistake. 1, 2, 3, 4, 5, 6. Oh, 1, 2, 3, 4, 5, 6, 7. Yes, okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. Then we have generated our target molecule in this case. There we go. Right? You see? So in this case now, like, we have generated our beta hydroxy that aldehyde, in this case. Right? Thank you very much. I will see you in the next class.